Greetings to all the students. Welcome back to the semester. My name is Pithia Dahal and I'll be teaching you Mechanics of Structure, MOS, and its subject code is 22303 as per MSPT. As you can see that this subject contains 6 units, and for each unit I have listed down its name as well as the weightage. So if you add up all the marks for all the 6 units, you will get exactly 70 marks. Let us start with the first unit, that is moment of inertia. So I would like you to understand the word inertia. The word inertia first. To understand this word inertia, let us take a block of mass m. Let us take a block of mass m, and let us say that this block of mass m is resting on a ground. It is not moving, but it is just resting on a ground. Now, I want to move this block. This block will move only if I apply some external force. Now, this is according to Newton's first law of motion. Newton's first law of motion states that any body will continue to be at its state of rest until and unless we apply some external force, right? So what it is saying is that this body here is completely in rest, and now I want to move this body. To move this body, I have to apply a force, and when I apply a force in this direction, this body will start moving, and it will move in this direction with acceleration a, right? So from the above diagram, I can say that my force is equal to mass into acceleration. Now, when this body starts moving towards this direction, there will be an opposing force acting towards the applied force. Let this force here be the applied force. Applied force. Right? So, when I'm pushing the body towards the right hand side, there will be equal and opposite force that will be pushing towards the left hand side, which is towards the applied force, and this force is known as an opposing force. Opposing force or resisting force. Resisting force. Now, why does this opposing force or resisting force acts towards the applied force? Why? It is because of the mass of this body. Because there is a mass of this body, this mass will act towards the applied force. So, inertia is nothing but an opposing force. Opposing force to the applied force. Right? So, let us see how the mass of the body affects the inertia. If my mass is bigger, let me compare 2 bags of rice. I'll take, let this be 10 kg bag of rice, 10 kg bag of rice, okay, and here let this be 25 kg bag of rice. Now, I'm comparing these two. So, from the diagram itself we can see that 10 kg has lesser mass. It has lesser mass as compared to 25 kg bag. This 25 kg bag has more mass. Now I'll be applying a force here to move this bag, and equal and opposite force will be acting from here, right? So which is the inertial force. Now if I compare it with 25 kg bag and 10 kg bag, mass of 10 kg bag is less than 25 kg bag, and therefore the inertial force that will be acting towards this applied force will also be less as compared to 25 kg bag. Now let me compare 25 kg bag with 10 kg bag. This 10 kg bag has more mass. It is more heavier, it has more mass. So when I apply a force here, it will again give equal and opposite force acting towards the applied force. So if I compare it with 10 kg bag, mass of the 25 kg bag is more to 10 kg bag, and the inertial force will also be more as compared to 10 kg bag. So from here what we can say is that mass is directly proportional to the inertia, which means that bigger the mass, more will be the inertia, lesser the mass, less will be the inertia. I hope inertia is clear to you. Just a simple explanation. Now let us go to moment. What do you understand by moment? So let me take an example of this plank here. Simple plank. Let us say this is a beam which is free at both the ends, and its length, let it be L. So I'm applying a force here, F. Now when I'm applying a force F here, what it will do, it will rotate. Since this side is free and this side is free, so because of this force here, it will rotate this beam in this direction totally, right? So this rotational force will be in a anti-clockwise direction. So from here what we can say, my moment is nothing but force into the distance, which is L, length of this plank. Now from this equation what we can say is that moment is nothing but it is a force, it is a force that is causing a rotational moment here. So we can say that moment is a type of rotational force, which is type of force that is causing a rotational force, right? Or otherwise you can say I have a plank here and this plank is fixed at both the sides. It is simply fixed at both the sides, and now I'm applying a force here. So what will this force do? It will bend this plank. Since it is fixed here, these two sides will not be able to move, and instead because of this force here, it will bend the plank. So what is happening? Because of the moment applied here, this applied moment is causing a bending in this plank. Now if I take an example of a door, how will the door be fixed? At its one end it will be hinged, right? So that it can rotate. It is hinged here, it is not fixed. So now I want to open the door. So what I will do, I'll apply a force here. Now this force is causing a rotation. This force is causing a rotation to this door. So what I can say, my axis will be here. Through this axis I'm applying a force, and this force, the moment that I'm applying, the force that I'm applying is causing a moment, a rotational moment to this door, and the door is rotating and it is opening. We can say that. So now altogether, what is moment of inertia? What is moment of inertia? It is nothing but a resistance against the motion. Resistance against the motion. Right? Motion, why motion? Because when I'm applying see in this diagram, let this be diagram 1. In this diagram, this whole plank is having some mass m. Now, because of this mass m, when I'm applying a force, it will have a equivalent opposite force acting, which is acting against the motion, against the moment of this direction of this applied force here. So what I can say, moment of inertia is nothing but it is the resistance against the motion. Now this moment of inertia is also known as second moment of inertia. It is also called as second moment of inertia. Okay, so this second moment of inertia can be defined as the product of mass times the distance. Now here, let this be the distance L. Let this distance be here, this distance here be, let this distance be L. So product of mass times the distance L from its axis and squared. So distance squared. So it will be equal to m into L square, where m is the mass of the product into L is the distance from the axis. So second moment of inertia, we can say it is resistance against the motion, and it is also known as second moment of inertia, which is the product of mass times the distance from the axis at which we are applying the force squared. Let me explain you with a lamina. Let us consider one lamina here. Let this be x-axis. Let this be y-axis. Now I'll take a continuous system lamina, not a discrete, but a continuous one. So let this be a lamina of area A. Now inside this lamina there will be many small areas which will make this big lamina. So let us say that in this point I have area A1, and in this point somewhere I have area A2, in this point somewhere I have area A3, and so on. It will go up to AN, because there are so many in here. You can say A100, this can be A200, any number. So I'm taking, just to explain it to you, I'm taking this 4 areas: area 1, area 2, area 3, and infinite area n, AN. Okay, so if I see the distance from y-axis to my A1, area 1, the distance will be x1, because it is going in a horizontal direction. Now the distance from here from y-axis to A2, let this be x2. Similarly for A3, it will be x3. Similarly for AN, it will be xn, right? Now if I want to know the distance from y-axis to A1, so this distance from x distance to A1 will be y1, right? Similarly, the distance from x-axis to area 2 will be y2. Similarly, for area 3, to reach area 3, it will be y3. Similarly, for this distance, it will be yn. Now from here, what you can say is that moment of inertia. What is my x1, x2, x3? My x1, x2, x3, so on up to xn is equal to, it is distance, right? Distance from the centroid of areas respectively from this x1, x2, x3 up to xn is my distance from y-axis, right? And a1, a2, a3 up to an is equals to my areas, right? Number of elementary areas. So again, y1, y2, y3 up to yn is again distance from x-axis, right? This is distance from y-axis. So from all this given data, the first moment of, we can say, first moment of area A1 about y-axis is equal to, I'm looking it from this direction, this is y direction, will be equal to this distance times the area. So it will be area A1 times the distance x1. Now similarly, I want to know my second moment of area A1 about y-axis. So what does it say? It says that it is the product of mass. So the mass here is having area A1 into distance is x1, squared, right? So this is my second moment of inertia. So this here is my moment of inertia. A1 x1 square is my moment of inertia. So similarly, if I look it from x-axis, first moment of inertia. First moment of area A1 about x-axis will be equal to, now I am looking from this x-axis, from this direction. So what will it be? My area A1 is here and my distance is here. So my area A1 into the distance is y1. Similarly, my second moment of area A1 about x-axis will be equal to mass, product of mass, which is mass here is area of the mass, times the distance squared, right? So in general, what can I say? In general, I can say that I x x, which means moment of inertia about x axis is equal to the summation of all the moment of inertia, which will be a1 y1 square plus, this is for the first one. Now if I go find the first moment of area a2 about x axis, what will it be? It will be a2 y2 square plus, now I want to find it for the third one. What will it be? a3 y3 square plus, so on it will go up to an yn square. So this will be in a generalized formula. In general we'll get this one, right? So even for Iyy, what will it be? Iyy, we will get a1 x1 square plus, this is for the first area a1. So for second area a2, it will be a2 x2 square plus, third one a3 x3 square plus, and so on an xn square. So this is a generalized form for Iyy, and for Ixx we have, by looking at this both the expressions for Iyy, which is Iyy means moment of inertia about y axis, and moment of inertia about Ixx means moment of inertia about x axis. So from looking at this equation, what we can say is that Iyy can be equal to summation of all the areas times the distance. So the distance here be Ix square, right? So from this above equation we can get this one, right? Similarly in here, Ixx will be equal to the total summation of areas times the distance. Distance is y square. So we have generalized form for both Ixx as well as Iyy. Now looking at this both generalized form, we can say that Ixx can be equal to Iyy can be equal to I. So it can be equal to, so all in all, if we write in a general way, we can get a area summation of all the areas, total area into the distance squared. So in general we have this formula. This is a general formula. Where A is the area of the section and H is the area of the section. And H is the distance from the centroid. Now I hope this is clear.